on software. So the security of that software is critical. Vulnerabilities can shut down international infrastructure and disrupt the services that we rely on. Over the last 3 years, software security has made the headlines more times than any of us would like. As the home for software development, GitHub has a responsibility to help. I'm Gray, the VP of Product at GitHub, for the security features that we build to help you write more secure code. For the last 4 years, my team and I have been embedding security into the developer workflow. We've shipped features like secret scanning, dependabot, and code scanning. Today, I'm here with some of the team to tell you about the progress we've made, the lessons we've learned, and what's coming next. I want to start with 3 critical insights that underpin everything that GitHub is doing in security. And the first of those is that developers are at the heart of application security. Developers write the fixes for vulnerabilities. We write the code that introduces vulnerabilities as well. And we're the ones that can prevent vulnerabilities from being introduced in the first place. That's why every GitHub security feature is built for developers. The second insight is that software security can be something that we collaborate on. We all want the software that we write to be secure, but we also want the open source code that we rely on to be secure. And we want the commercial services that we use to be secure too. There's a long history of companies, even competitors, working together on software security. And just like we all benefit from open source and the collaboration that creates it, we can all benefit from collaborating on software security. Each of GitHub's security features is built to empower the community, to make it easier for us to collaborate and together to secure software. The third insight is that managing software security at scale is a critical specialist role. Developers might be at the heart of application security, but it's normally security teams who take responsibility for it. And those teams need to understand what's happening across thousands, tens of thousands of repositories. Those teams are also full of unique experience and expertise that we can all benefit from helping scale. Each of GitHub's security features is built not just for developers, but for security teams operating at scale. You'll see one or more of those 3 themes in everything that GitHub is doing in each of our security features. So, what's new? Well, the short answer is a lot. Since GitHub Universe last year, we've shipped over 100 changelog posts for improvements to our security features. And some of those were big leaps forward, like community contributions to the GitHub Advisory Database, or push protection for secret scanning, or making our organization and enterprise-level security dashboards available to all GitHub Enterprise customers. Some of those changes were much smaller, like making it possible to comment in a pull request on the code scanning alerts that appear there. And those small improvements add up. They're what it takes to build security tooling that developers want to use every day. And of course, today, we've got some announcements that we made earlier in the keynote. You heard Brittany announce private vulnerability reporting, the GA of CodeQL support for Ruby, and an expanded security overview at the organization and enterprise level. More on that in a moment. But first, I want to talk to you about something we launched in April of this year, and that's secret scanning as a push protection. I want to talk to you about secret scanning because it is a great example of the difference we can make when we embed security in the developer workflow. It's also, perhaps surprisingly, a really great example of the difference it makes when we work together as a community. So, every day, hundreds of credentials are leaked on GitHub. We know because we scan every push to a public repo for them. On an average day, we found around 300 GitHub personal access tokens accidentally exposed. So what do? Well, we automatically revoke them, and we notify the owner of that token. And it's not just GitHub tokens that we do that for. We work with 60 partners to help keep their customers safe if their API keys are leaked in GitHub public repos. Here are just a few of the new partners from this year. We onboarded 14 new partners over the last 12 months. So if you leak a SendGrid, a DigitalOcean, or a Meta API key in a public repo on GitHub, we will send it to that service provider, and they will automatically revoke it. So go forth and leak DigitalOcean keys in public repos with impunity. But having an API key revoked, well, it's not the best developer experience. It would be better if we prevented that leak from happening in the first place. And that's exactly what we do with secret scanning as a push protection, which launched in April for GitHub Advanced Security customers. With push protection, we can scan pushes before accepting them. And if they contain secrets, then we reject them. Last month, that helped Advanced Security customers prevent over 1,400 credential leaks. And it did so whilst keeping a really great developer experience. How do we do that? Well, first off, we make it easy for a developer to override the push protection if they need to. You don't want to block your development team when they're pushing something urgent or critical. Secondly, we only block pushes that contain what we know to be a secret. Cases where there's a less than 1% chance that this is a false positive. And we achieve that low false positive rate by working with the token issuers themselves. DigitalOcean is, again, a great example. As well as partnering with us to automatically revoke findings in public repos, they updated the pattern that they use when they're generating new tokens, and they made it highly identifiable enough that we can reject pushes that include it. If you want to learn more about secret scanning, then Mariam Sulakian has a fantastic talk on this as part of the virtual schedule. I highly recommend you watch it when you get home from Universe. But I hope you can already see that secret scanning is built for developers and how it takes a community approach. It's a great example of two of the three themes I'd mentioned earlier, the difference we can make when we truly embed security in the developer workflow, and the impact we can have when we, as an industry, collaborate. Talking of collaboration, I'm going to introduce Justin Hutchings, our Director of Product for Supply Chain Security, to tell you more about securing the open source software that you use.
You know, open source is such a ubiquitous part of technology today. It can be easy to take for granted. But if you look back maybe 20 years ago, developers like you were writing your own code for things like HTTP, databases, or XML parsing. We didn't have fancy YAML back then. You know, today these are things we all rely on open source to do. And it allows each of you to build your experiences faster than ever on a huge supply chain of open source software. Last year, we got a stark reminder about the importance of keeping track of vulnerabilities in the open source you depend upon when the log4shell vulnerability dropped. I think we're a slide behind. Folks want to advance that? Super, yeah. Log4shell affected almost every Java developer on the planet. And since then, open source maintainers have published thousands more vulnerabilities across all of the ecosystems. And you know, that's what dependabot is here for. It's here to help you focus on the things that you want to do, to allow you to innovate and build the things you want without spending time keeping up with vulnerabilities. But securing the world of open source is a bigger task than any one person can do. It's a community effort. And I want to look back on some of the ways that we've partnered with members of the community to make dependabot work better for you this year. First, I'd like to talk about language support. Over the past year, we've added support for 3 new languages in dependabot in partnership with the community. Starting with Dart, we partnered with the folks in Google to actually deliver Dart support when they contributed that directly to dependabot's open core to add support for the language. We also addressed one of the top upvoted comments on dependabot core and added support for Yarn v2 and v3. And finally, we added support for Rust with great thanks to the RustSec group and their tireless efforts to make sure that the vulnerabilities are well curated. We also shipped an exciting new API that allows developers to upload a simplified software bill of materials, or SBOM, of all of their dependencies. And we've seen developers across the community taking advantage of this, bringing support for scanning things like Gradle or Scala into dependabot. These community partnerships allow us to meet you where you are so that you can stay on top of the latest vulnerabilities in whatever tooling you decide to use. Now, you may be less familiar with our advisory database. That's the database of all the vulnerabilities that power dependabot. Our team of curators reviews all the vulnerabilities from the National Vulnerability Database, of course, but we also review and issue CVEs on behalf of maintainers like you on GitHub. We're super proud of this year, we issued more than 1,100 CVEs on behalf of open source maintainers to help them reach their communities and let them know about new problems. Thanks to your efforts, GitHub is the largest independent CVE issuer today. And a really unique part of our advisory database is that it's truly open source. You can check it out at github.com/advisories, and all of the advisories we have are available under a Creative Commons license. It's free for everyone. This year, we also opened our advisory database up to suggestions from the community. And I'm so thrilled to say that since launching that feature back in February, we've had more than 700 improvements from members of the community to make dependabot more accurate. So dependabot's come a long way this year, in no small part due to contributions from the wider open source community. But maintainers told us there's more we can do to help them with a really painful part of development. And I'd like to invite Kate Catlin to tell you more about this problem and what we're choosing to do about it. Thanks.
We need to talk about vulnerability reporting in open source. So let me start by giving you the 10,000-foot view of how it works today for those of you who have not been through this process. So first, there's a security researcher, and they find something. And they've got to tell the owner of the project that has the problem. So sometimes that repository has a link or an email address, and then it's not too bad. But I often hear from researchers that they spend hours trying to find just somebody to disclose to an email, and that's just to kick off an exchange that can go on for months and leave everyone exhausted. So we're not going to go through all these problems right now, but to sum it up, I've got a quote for you from an actual security researcher in our UX studies, which is, "I think most people just don't disclose since it's so much work." And that's a shame, because what the OSS community needs is a high trust and collaborative relationship between OSS maintainers and security researchers so we can all be safer. And we think GitHub has a pretty important role to play in that. And that's why I am so excited to demo for you today our newest feature that we believe resolves a lot of the challenges in this process, which is called private vulnerability reporting. Okay, so this whole process starts with a security researcher. So let's pretend that this is an ultra-popular repository and not a test repo that I just spun up, and you found a problem in it. So what you're going to do is navigate to the Security tab, and then the Advisories menu, and there's this nice inviting green Report a Vulnerability button. So quick aside. Those of you who have created a draft security advisory before, this is the same form. Don't worry, that's intentional. What we wanted to do was bring the security researcher into your existing process and help them help you. So it's all in the same place. So I'm going to fill out just the title and description. Great, and that's actually all I have to do to submit this form. We do, however, know that a lot of security researchers love the details, and they've done a lot of research on the details already. So we left you the rest of the fields here. If you want to fill out all the metadata, you are empowered to do so. So we'll click Submit Report, and you are automatically credited already for that report. You can also jump into this temporary private fork and start resolving the whole darn issue for the maintainer if you know how. But the most important part of this feature right now is that it's private. So as of right now, the only people who can see this report are me, the person who submitted the report, and the owners of the repository, so they can see the report. So how does this go from this super private channel of communication to a public, sending dependabot alerts kind of advisory? We need the maintainer. So let's switch over to a different browser where I am logged in as the maintainer of this repository. We'll go back to that Securities tab. And wow, someone has submitted a very scary vulnerability for my review. So if this bug is actually a feature, you'll scroll down and just hit Close. Otherwise, you're going to hit Accept and Open as Draft. And then it's just like a draft security advisory if you use those today, with the difference that the reporter is still involved as a collaborator. So if you've got follow-up questions, you can jump into the comments and ask them there. You can also, again, jump into that temporary private fork and start collaborating with the maintainer to fix the problem. And in a perfect world, the security researcher has filled out all those fields for you. So you wake up in the morning, you're drinking your morning coffee, and this is already done. But even in that most perfect of worlds, the reporter cannot merge that temporary private fork for you, nor can they publish this advisory for you. That is on purpose. Again, we want to make sure that you, as the admin of this repository, still have full control over what is published to it. So let's compare. We've got the situation today and this situation after private vulnerability reporting. We have eliminated the challenge of finding contact info, because it's just a form. We have eliminated the challenge of the reporter not knowing if anyone received this or is doing anything with it, because they can see the status the whole way through. We have eliminated the challenge of maintainers trying to triage reports from wherever they're getting them all across the internet by putting it in one central location, which is the same place you resolve it. We've eliminated the challenge of maintainers errantly not actually fixing the problem, because the reporter is still involved and can test the solution that they've come up with. And last but not least, we've eliminated the challenge for you security researchers of getting credit, because it's now automatic. As part of our launch, we're so excited about this. Everyone's excited about this. All these organizations were excited about this. So they signed up to have this turned on before it was even launched. So that means if you find a vulnerability in any of these orgs today, you can submit it through this incredibly easy process henceforth. And last but not least, if you want this feature on your repository, navigate to repo settings, and then you'll hit code security and analysis, and it's the first listing on the top. So all you have to do is click enable. Once again, we're super excited about the difference private vulnerability reporting is going to make, but we also want to prevent vulnerabilities from happening in the first place. That's why we built GitHub code scanning, and we have lots to tell you about that. So please welcome our VP of Engineering and one of the creators of CodeQL, Pavel Augustinov.
Thanks, Kate. That was great. Brave doing a live demo at Universe. I admire that. So just to recap very briefly, as we've just heard from Gray and from Justin and from Kate, at GitHub, we believe in putting great security tooling at developers' fingertips. With secret scanning, we protect developers from accidentally disclosing important credentials. In supply chain security, we help them bring the power of open source to bear safely and confidently. We are paving the path for security researchers to collaborate more closely with open source maintainers, and we provide a free and open database of security advisories that helps everyone. So where does code scanning fit into all of this? Well, if you haven't come across it before, think of it as something that helps developers write more secure code by preventing vulnerabilities from ever hitting the main branch of your repository. Think of it as an automated security reviewer that warns you if a code change introduces a potential vulnerability right there in the pull request flow. Code scanning itself is a platform helping dozens of partner and open source analysis engines integrate tightly in the developer workflow. However, we're especially proud of our in-house analysis engine, CodeQL, which is used by the vast majority of code scanning users. So to put that into perspective, I thought I'd share a few stats. Today, CodeQL supports 9 of the most popular programming languages on GitHub, and thus it applies to the majority of all pull requests. During a working week, we typically run over 150,000 analyses each day across more than 100,000 repositories, both public and private, and we flag potential vulnerabilities in over 400 pull requests per day. Many of them are addressed before the pull request is ever merged. Of course, that's the best way of addressing a potential security bug. In fact, over the last 30 days alone, our users have addressed tens of thousands of alerts, some of them in pull requests, but others lurking in the baseline of the existing code. And that's just the current state. But CodeQL's analysis capabilities keep getting better. Just looking back over the past year since GitHub Universe, we've added lots of new analyses. Out of the box, we now have 25% more queries and protect you from many more vulnerability classes. CodeQL covers every single one of the SANS top 25 list of most dangerous weaknesses. We cover 96% of the threats identified in the Web Application Software Consortium. With dependabot, code scanning covers all applicable OWASP top 10 entries. But what does all that mean? It means our users are protected from more types of problem as they go about their daily work. And the number is, of course, still growing. Now, what does it look like to bring static application security testing into the developer workflow? Well, as I said, it's a bit like having an extra security expert on your team who chimes in on code reviews when they spot something. Behind me, you can see this in action. This is an example of code scanning on the Brave browser, posting a comment, identifying a vulnerability right there where the problem occurs. It can be discussed, just like any other pull request feedback. Should you address it now or later? What's the best way of mitigating it? Best of all, once you implement a fix, it will be resolved for you, allowing you to merge with confidence. At last year's GitHub Universe, we launched CodeQL support for analyzing Ruby in public beta, and over the past 12 months, we have almost doubled the available analysis rules for Ruby and incorporated feedback from dozens of beta users who have fixed more than 4,000 alerts in their Ruby code. Now we're ready to call it GA. And as we look ahead, what's next for CodeQL? Well, we expect to bring its capabilities to the most popular mobile app ecosystems, with Kotlin and Swift support shipping in beta in the coming months. If you're interested, there's a talk by our very own Tony Torralba on some early success stories here, finding real vulnerabilities in popular Android apps. With that, I'd like to pass it over to our very own Jen Shelkopf. Jen wasn't able to be with us in person, so we got her to record what she wanted to share with you.
Thanks, Pavel. Hi, I'm Jen. I'm the product director for Secret Scanning and Security Overview. I wish I could have joined you live, but I am 38 weeks pregnant today, and I thought it would be best to pre-record this. But hey, at least I got to finish my part early. Today, I'll be talking about one of the biggest challenges with application security in organizations, and that is managing code security at scale. At GitHub, we believe that developers are at the heart of application security, and we've been focused on embedding security into the developer workflow with features like secret scanning, dependabot, and code scanning. But in most organizations, developers don't work on securing software alone. They collaborate with security teams. Security teams think holistically, and they need tools to help them work across many different repositories. Today, I'll be talking about how you can manage GitHub security features at scale, and I'll highlight Security Overview in particular. There are two big challenges that you face when working across many different repositories. The first is driving adoption. This could be a one-time activity where you turn on security features everywhere, or it could be a gradual rollout across teams. The second big issue is driving remediation. As security features are turned on, you're likely to find a lot of pre-existing issues that need to be resolved. With this information, you can work with developer teams on burning down your security tech debt and fixing any new findings in a timely manner. Let's talk about driving adoption first. To help security teams who are working across lots of repositories, we've introduced the ability to enable security features at the organization level. Today, you can enable dependabot and secret scanning for all repositories in your organization in one click, and you can ensure that they are enabled for new repositories as well. We're also working to support this capability across all organizations in your GitHub enterprise. Today, you can enable secret scanning and push protection for your entire enterprise, and our vision is to do the same across all of our security features. Now that you've seen some controls to drive adoption, let's talk about how you get visibility into how it's going. To do that, let's take a look at 2 new pages in the security overview. Now, the security overview is a page at the organization level that helps you to understand what's happening with GitHub's security tools across all of your repositories. We recently made it available to all GitHub Enterprise users, and it shows just the data that you have access to. Within Security Overview, the new coverage page is laser focused on helping you to understand and track adoption of GitHub security tools. The 3 tiles across the top show the percentage of repositories that have each feature enabled. And soon, you'll be able to see those percentages over time as well. In addition to showing you which features are enabled, we've highlighted a key capability for each one that we recommend you utilize. For example, the code scanning tile shows how many repositories have enabled alerts and pull requests. An important capability that surfaces newly added vulnerabilities right in the pull request, so the developer can resolve them before the code is merged. Finally, the repository table at the bottom shows you the current status of each security feature for a given repository, and it supports filtering and sorting so you can focus on the repositories that you care about most. Next, let's talk about driving remediation of alerts. The new risk page focuses on just one thing: helping you to understand and drive down the security alerts across your organization. Like the coverage page, there are 3 tiles across the top that focus on GitHub security features: dependabot, code scanning, and secret scanning. For each, you can see how many alerts are open across your organization. We plan to highlight key metrics for each feature. For example, we're experimenting with mean time to resolve dependabot alerts. The risk page also lists repositories on the bottom of the page and indicates how many alerts are open for each security feature. Like the coverage page, the risk page supports sophisticated filter queries to help you target the subset of repositories you're most concerned with. For instance, you can check how individual teams are faring with resolving their alerts. This will help you to drive remediation with the teams and repositories that you're targeting now. The last thing that I'd like to talk about is the vulnerability alerts pages. The vulnerability alerts pages surface all the individual alerts that have been created across your repositories. They look and function similarly to repository alert lists, but aggregated at the organization level. Here you can filter and sort alerts by specific criteria, and each view also gives you the ability to click into specific alerts for more details. Say, for instance, that you learn about a new high-risk dependency vulnerability. If you use the dependabot page to search by that dependency's name, you can see how many related alerts have been created across your organization. Once you know this, you can quickly follow up with the engineering teams that own each of these repositories to ensure that the risk is quickly remediated across the organization. So we've looked at some ways to manage code security at scale, including new pages and security overview that you can now use in your organization. Now Gray is going to recap all the progress across our security products and how to learn more about our new features at GitHub Universe.
So, So let's recap. Pavel and I both talked about preventing vulnerabilities with code scanning and secret scanning, respectively. In both cases, GitHub is building security tools for developers that embed security deep into the developer workflow. Secret scanning as a push protection is like an "Are you sure?" prompt when you're pushing a secret. And code scanning is like having a security expert on your team who diligently reviews every pull request. Both are built around the idea that developers are at the heart of everything in application security. We heard from Justin and Kate about private vulnerability reporting, which we're launching today in public beta. Private vulnerability reporting is really all about the impact when we empower the community. It's built for maintainers to make it easier for them to have a fantastic security disclosure process. But since we all rely on open source and the work of those maintainers, the impact of that ship is magnified. We'll all benefit from the reduction in 0 days that private vulnerability reporting will cause. And finally, Jen talked about what GitHub is doing to make our security features work at scale, with the expansion of our organization and enterprise-level security views. As we build security into the developer workflow, we also need to empower security teams. GitHub's organization and enterprise security overviews give security teams the insight and oversight they need to maximize their impact. GitHub is doing so much in this space. There are 90-something changelog posts that we didn't get a chance to talk about. And across all of those improvements, I hope you can see that GitHub is also focused on the areas that make the biggest difference. We're committed to embedding security into the developer workflow, to empowering the community, and to supercharging the impact of security teams. By doing so, we're helping millions of developers build more secure software. Thank you for listening, and stay secure out there.